Hello and welcome to our December Tech Talk with Bram. Bram, thank you for taking the time with us to share your insights as always.
Mhm.
We're going to do something a little different today, and we're going to start off with an announcement. Our announcement regards the Cloud Wallet and some new features that were recently added. I'm sure people have seen that Gene has posted that you can now manually link your bank for by XCH. So this is the process of providing your routing number and account number. You receive a microtransaction with a code, and then you provide that inside of the Cloud Wallet in order to link your bank. It can take 1 to 2 days for that linking to occur, but definitely a great option to access without utilizing your actual bank login information. Another new feature is a new create page as well as recovery flow for vaults. This is one of the most desired features as of recent, and it's because previously, if you had created your vault with a passkey and you tried to recover it, you still had to use a passkey when recovering. Now, with the new create and recovery flow, you have the ability to recover and change from using a passkey to using the Chia signer, which is currently on iOS and being developed for Android. And there's even an option to use Chia Signer as a recovery key. So that's our third new feature being added to the Cloud Wallet today. This will give you the ability to use that Chia Signer as your recovery key. This is part of the reason that there's a new create page and that a new recovery flow as well. Bram, did you have any other points on these new features for the Cloud Wallet and how they're going to enhance the ecosystem and security?
I've actually been more working on the next generation thing, like beyond this one, where the feature of that is going to be having timeout periods, like making good use of those. So that's going to be what we have now is a multi-sig experience. And the plan is we're going to keep supporting a multi-sig experience, but we'll have a more featureful thing in the future that's going to support um, having cancel periods. So if a bunch of signers try to do something, all the other signers are going to get warnings on their wallet, hey, someone's trying to do this thing. Like, do you want to undo it? And then you can undo it if it's not actually properly authorized.
Yeah, I know that's going to be a great feature as we bring in more enterprise focused items and also users who just kind of have a more diverse or robust need for their own vault security.
Yeah, it's more complex in some ways. Like for things that just go through instantaneously, there's much less uh it- you get these complicated threat models where you want it to be that even if one signer tries to DOS the system by initiating too many transactions for everyone else to cancel all of them, that can't happen. So it has a bunch more overhead. Not totally sure how completely consolidated will make the whole thing. That's a little bit TBD. We might or might not uh, make a sort of a midway thing. Probably not, actually. I think you kind of have to go whole hog of like either you are fully supporting like all the crazy scenarios, or it's just sort of like, well, if you hit the threshold, you can drain the wallet instantly.
Right, right. And as you mentioned, it'll have different CLVM costs, which is different fees and all that kind of stuff
Yeah.
associated with which option.
Yes.
Well, thank you. So those are our new features for the Cloud Wallet. Make sure you guys check it out at vault.chia.net. And if you have any questions or run into any issues, feel free to jump into our Discord server, and we're always happy to help in there. That being said, we want to get into the tech talk, and we've seen some recent updates on the POS2 as well as Chia Gaming. If anybody does have questions throughout the tech talk, please do use the Zoom Q&A. We also monitor our Discord channel in the community feedback section, and we are watching the YouTube questions to capture what we can from there. But regarding Proof of Space 2, Bram, do you mind going over some of the high-level recent updates that we've seen?
Yeah, there's two big algorithmic things that we figured out. One of them is we can stop at table three. So the way this works is you generate tables one and two and three. And then when you get up to table three, you drop a whole bunch of the data and you encrypt all of the values. And so now they're kind of incompressible because they're all encrypted. And we figured out you can stop right there. You don't have to do anything further at that point. You don't need a tables 4 and 5, which uh, is really beneficial in a few ways. One, it makes the format much simpler and the whole thing. It makes plot times quicker because you don't have to generate tables 4 and 5. Um, and it means we drop things like Banish compression, which we put a lot of time and effort into figuring out really great ways of doing Banish compression. That is great work, but uh, a little sad to see it go, but the expedient thing to do is to just skip the need for it entirely. The whole point of having that there was that was potential compression that we wanted to make sure we actually did properly. But now we just engineered it completely out of existence. So yeah, so now your plot is just a single table that's I was saying it's a single incompressible encrypted blob, which people found that phrase really funny. The what we had before was kind of that technically that already, although there's a question of what compressible means. And actually, even with table three, it's a little bit compressed already because it's basically a list of these like 56-bit values, which are all encrypted, but it doesn't care about their order, so it like sorts them and then delta encodes them. And the delta encoding is a form of compression, but you can do that essentially optimally with just a tiny bit of trickery. Um, uh, yeah. Yeah. Um, and now I'm thinking about compression algorithms. Um, but yeah, it makes it so that the attack surface of potential compressive techniques you can do on the whole thing is very, very small. And the all the stuff to block grinding is done on by adding costs to doing the calculation of table three because that has the encryption step. So we had a lot of concerns about goofy things people could do to compress tables 4 and 5. Um, Kind of a bigger attack surface on those because the actual amount of compute going into calculating tables 4 and 5 after table three is relatively small. But when you make tables 4 and 5 not exist anymore, you no longer have this problem. Um, yeah, so this just feels really, really good all around. The other new thing we added in, and this is kind of sexy, is we actually added in sloth to it. Um, the sloth is not quite a VDF. It's like almost a VDF. That it doesn't it's much much simpler, but it has a lower limit on what ratio it can get between the whoever's doing the calculation and whoever's doing the verification. Um, but we can make it so that when you're doing the table three calculations, the thing that actually is costly is using sloth. And we can do that on probably, I think it's 112-bit values, which means we can get a ratio of 112 between the costs of doing the compute and the costs of verifying it. Which means that the load on verification is very, very low. So one of the bottlenecks in terms of the security we can put on is how expensive is it to verify? Because you don't want people who are validating the blockchain to have to do a lot of compute. So because we can throw in this pretty substantive literal 2 orders of magnitude ratio there, it's nice if it's an asymptotic rather than sort of kind of a constant. Um, but that's a pretty substantial constant right there. So that really helps a lot with the numbers and the parameters that we're using for the whole thing.
Yeah,
Oh,
most
and another
certainly.
thing I should mention, actually two things I should mention, maybe three. Okay, one thing is we're sticking with just K28, and because we're dropping tables 4 and 5, basically individual plots are just a gigabyte. I'm old enough to think saying just a gigabyte sounds ridiculous, but they're just a gigabyte. And um, and because of the simplicity of how it's all set up now, they can be striped. So you'll be able to take a group of plots that are all related, and we will at the protocol level set it up so that they all pass the plot ID filter at the same time. So you care about the same places in them all at the same time. And you can stripe their sections on disk. So the reads that you have to do on disk to get them out are just one seek for the whole lot of them. And it'll come up at the same time. So this is much lower disk load doing the reads on all these things, despite them being very small plots. And in the extreme, it makes it so you can fit the entire thing just on one drive. A whole group. A drive is only doing one group. So that way you can actually spin down the drive and have it have to wake up on the order of hours or maybe even potentially days. Um, in order to come back again and do its lookups and respond to challenges and then go back to sleep again. Um, when it gets into days, then you're adding a lot of variance to pooling protocol when you do that. But uh, um, yeah, so we can make that work quite well in part by it turns out the plot ID filter, that's the part of filtering which says that you don't even have to do lookup at all. We realized that that's actually very special, and there's all kinds of crazy things that can be done for that that are different from the other stuff. Um, and the final big thing that we're doing is we're adding in a concept of strength. So there aren't going to be different plot sizes. We're doing this concept of strength, which is you can voluntarily uh, put more computational expense into making your plots in the first place. And we talked about doing these things before. There was sort of kind of this view originally that bigger plots did this, but it turns out they don't really. So we're doing this fixed size plots, but different strength. Or there's some controversy about what a good name for this is. Some people have talked about calling it Riz. Anyway, the you have the option of what strength you want to plot at when you start. And you can essentially you can double the amount of compute you need in order to do your initial plotting, and in exchange for that, you will have the disk load that you otherwise would have had on it. So that's just a trade-off you can do, and obviously your total load is the sum of these two, right? So if your costs are dominate, if your load, electricity, whatever costs are dominated by one side or the other, you can adjust the strength that you're doing to lessen the sum total that you're putting in.
Yeah, thank you. And it's been really impressive to watch the development of the proof of space, how it's changed. And now that we're at a point where we have even less compressibility, even less plot grinding ability, and a better support for the farmers themselves with the power down impact and then also strength. I know there's a little confusion as to how the two of those can work hand in hand. Being able to set a plot grouping where you might only have the plots checked once a day, and how that compares to adjusting the strength to reduce your disk IO.
Um, well, with plot grouping, what you don't want to have is a significant fraction of all net space is all in one group, right? So we're going to have a limit on group size that makes it so you can't put a significant fraction of all net space in one group. Um, the um, it, the size of the group is kind of up to you. Up to some ridiculous maximum. You can put any amount of stuff in a group that you want, essentially. Um, limit's probably going to be like no more than 2 to the 16th, but something ridiculous, like enough that you can totally reasonably fill up an entire hard drive with these things. I think technically like a 65 terabyte drive filled with plots would go more than a 2 to the 16th limit on your on your groups. Um, so that seems to be a pretty reasonable limit for that. Um, just because you don't want it to be too ridiculous. But there's no real, that's the only real limit on that, is you don't want it to actually impinge on being a significant fraction of all space. So you can sort of assume that you want to, you basically always want to group things together. At some point, it stops giving you much of any extra utility unless you're completely spinning a disk down. So obviously, if you can completely spin a disk down for hours at a time, that's savings. If you're never doing that, if you're just leaving it running, there might be utility in spreading things out. So we'll have another parameter for that where you can set things to be have two different groups that are dissociated from each other, because that way, if you have a bunch of independent things on the same drive, you know that you'll only have the load pattern will only have to pull out a few of them at a time, right? Like that. So there won't be one challenge that you have to pull a whole bunch of things happenstance at the same time out of the same drive, and you won't. But the load on doing that will be a little too much for that drive to do. So we're going to have both of those parameters there for how you tune things. Um, the Riz is sort of kind of a different thing. The Riz determines how long it is between times when a given grouping needs to come up. That's a very straightforward trade-off. And so it's a pretty straightforward. If you want to divide how often you need to do your lookups by two, it's going to multiply the amount of compute you need to burn generating the whole thing by two. That's just kind of how the trade-off works.
Gotcha. Thank you. Yeah. So effectively, grouping will determine all these plots are going to be accessed at the same time, and strength
Yeah.
determines how frequently they're going to be accessed.
Yeah. Yes.
And going on
Oh,
the
and
strength, oh, sorry.
when you have sizes of groups, you do kind of have diminishing returns on the utility you get out of sizes of groups. Uh, because the it increasingly gets dominated by the reading rather than the seeking. So even if you have the ability to do, if you have a very large drive and you're not powering it down, the amount that you lose by not making your groups bigger above like groupings of like 512 or something of them is not that much, and you might gain something by spreading it out more evenly. Yeah, so people will have configuration parameters to play with. It's probably getting into very high levels of optimization here. It's pretty good even with defaults. So yeah,
Absolutely. And I know, we've seen people plot all the way up to K41s and ridiculous sizes. So even outside of just optimizing their stuff, I'm sure a lot of people will play around with these to see who can create the strongest plot, who can create the largest group. And
there might be a little bit of a game of someone wanting the bragging rights of having actually made a block with the highest riz that anyone has ever done.
yeah, it'll be interesting for sure.
Yeah.
And just a little bit more focus on the powered down aspect
Uh-huh.
of grouping these together to make sure that, hey, all of the plots on a particular drive are going to be accessed at once rather than at random intervals.
Yeah.
What happens to the economics of Chia farming and how does that actually affect the end user? Plus, what happens
Uh,
on consensus?
well, people who aren't farmers aren't going to notice anything. It's not, it doesn't matter to them. I mean, it's good in that it'll make our Nakamoto coefficient go up. Um, uh, uh, yeah, but for people who are farmers, well, it's two things are going to happen. Number one, they have to replot. And number two, uh, after their replotting, their electricity bills are going to go much, much lower. So if you're doing compression now, that just goes out the window. No more compression. Not happening. Nick who's been the main driver with me second on the new format, was one of the primary people who figured out those techniques. So, and we have come up with these techniques for fighting it, which are very much in the direction of simplification. So, it feels really good. So high confidence that there won't be any new compressive trickery anyone figures out. Um, and yeah, I mean, yeah, that's the main thing is so yeah, so there won't be any of this just outright grindy stuff. And even within that, there will be this ability to do crazy like power down trickery with drives. And possibly also in principle, I think it should be possible to lower the electricity bill on drives by making them spin slower. Except my understanding is nobody knows how to do that. That's like, like nobody ever has that need. So like the tool chain for playing such games on drives just isn't out there. But in principle, you could use that uh, with the stuff that we're doing.
Gotcha, gotcha.
So
And from a
crazy things.
consensus perspective, how is this enforced to make sure that, this plot group is read at one time and there's a gap until it's read again?
Everything about the proof of space format, it's weird because the actual consensus algorithm, which is in some sense the real specification, only very tangentially hints at how plot format works. It's um uh, more so with the new one that we're doing, there's a single very clear canonical plot format where really only that and small variants on it are the only things you could even vaguely practically do. Like very intentionally so. Um, but we're doing a hard fork, so that's changing things, right? And there will be a transition period where the quality of old ones slowly, or well, that's technically not quality. Um, Old plots have an increasing likelihood of being invalidated over time until it's 100%. Or the proofs that they get have to pass a new filter that at first is, 1 in 256 of failing, and then goes to 2 in 256 and failing, and so on until it's just guaranteed it just fails. Um, so that's um, so yeah, hard forky stuff. We also have a whole bunch of unrelated security stuff we're doing for 3.0 as well that we will be documenting. It's all very boring. It's all like some kind of performance cost stuff in there. It's not the whole idea is we want all of it to be like so boring. Everyone's like, why are you even asking for community feedback? This is stupid. If we get that as the feedback, we have done our jobs. Um, uh, but there are going to be hooks that say so for plot groups. Let's see if I can get this exactly right off the top of my head. The um there's going to be a an index that's for the um, decorrelation between things. So a plot, there's going to be a concept of a plot group, and then there's an index within that. And that as a whole determines the individual plot ID. And almost the entirety of what you associate with being the plot is within uh, the is within the plot group information. Um, and the only thing sitting outside of it to finally calculate the exact plot ID is just the index number within that. That's just there so you
Right.
can have multiple ones of them, and that's like 2 bytes that are hashed in at the end. So there is an index within the plot group information, which also has the public key, the farmer key, the blah, 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 all the stuff that you're used to there. There's an index in there, uh, which is just a number, which just has the property that if you make two different things which only differ by that number, they are guaranteed to have to do lookups at different times from each other, and that is all related to the uh, uh, yeah, so that is decorrelating on when you that is decorrelating when you pass the plot ID filter. That's before you actually have to even go look at the thing, right? And then the everything within the same everything that has the same plot group ID uh, gets the same challenges. So its data is going to include is going to be it's like original X values that it uses when it makes its plot. Those are affected by the index number. But whether it needs to do lookups and some of the stuff about where in it you need the lookups, that is all determined from the group ID. Um, so uh, it looks if you look at it from the real spec, which is the validation code, it's written a little inside out and backwards from that motivation that I just said. But that's the basic idea. You make a whole bunch of things that have the same plot group ID and in some sense are almost the same plot and just have different indices. So they have different data, but all their semantics are essentially identical. And that's a plot group.
Ah, makes a lot of sense and very impressive as to, how complex this gets, but yet how simplified it's going to end up being for the end user to be able to determine, okay, this is my plot group and this is
Yeah,
my
well,
strength.
so much of cryptography by necessity is just black boxes that you just don't
Mhm,
see. Um, so like with Chia gaming, it's interesting like what is and is not considered cheating. So there's this classic game that two people play where one person says a letter and the next person says another letter and then the first person says a letter again. And these are forming a word. And then at some point, someone either how does this go? So someone either finishes a word or I forget if you finish a word, you win. Or the other person challenges saying, hey, wait, there's no word that starts with this sequence of letters. Um, so this is a game that can be played between two people with no auditing whatsoever.
mhm,
And the Chia Gaming is kind of doing the exact same thing, but it includes secure hashes. Now, a secure hash is something that you, with your puny little human brain, can't do in your head. But, your old Commodore 64 totally could have done that. It's not it's not an expensive operation to do at all. Um, but it has that same uh, ethos to it. Um,
mhm,
Uh, uh, yeah. Uh, but cryptography in general is very complicated, but it's a bunch of black boxes. So it's considered like obviously
mhm.
it would be considered cheating for your computer to make um, uh, game decisions for you when you're playing a game, but not cheating for it to do the secure hashing for you. Obviously, obviously that's that's just considered normal for the computer to be doing that part of your play for you because your puny human brain can't do secure hashes. Um, but in general, cryptography acts like these black boxes where the cryptography itself is complicated and insane. um, but you just use it and it just kind of works. And the interacting with it is very straightforward at a high level.
Now, you touched on an interesting point, and that's the security aspect of POS2 and how it's going to differ from POS1. We have a question from one of our users,
Yeah.
Janny, and who is actually reviewing the POS2 security stuff? Do we have anybody external
Um,
who's doing reviews?
you know, okay, well, there's two things going on here. There is the fundamental construct that we're doing, and there's the implementation details of it, the actual code that we do. I'm not sure. We have our internal reviews of these things, and Bram V is our internal person who does security reviews of stuff. Um, and this obviously is all open source. I'm not sure if we're going to pay an outside firm to audit the new code for POS v3. Um, Unfortunately, like the new proof of space algorithm, I don't think the outside firms cannot audit that from an algorithmic standpoint. They're basically two experts on that in the world, and they're me and Nick, and there's no. We have advisors. Christoph has been working with us on this as it goes through. We will do something, I think, to try and get more feedback on it, but um, it is something where it's difficult. There's so few experts on the proof of space itself, but we're treating the actual code implementation parts of it the same way we do everything else, and with this very high degree of the heightened degree of security of everything that touches consensus, because that's kind of terrifying. Uh,
Yeah, thank you. And another follow-up question regarding the proof space itself. Janny had noticed there's some work on AES and I hashing. Can
uh-huh.
you explain, like, we're five, on how that's used and where?
The um there's a few different places where things are done in it. Um, the the biggest thing is um when you're matching things together. Well, actually, okay, there's two basic places. There's kind of three places where it's used, where we're doing stuff. Oh, actually, really two. So the one place where encryption slash hashing is used is in the matching algorithms. So this is the thing that's kept over from our original proof of space. So original proof of space algorithm is very much here still. It's just from the original one, we cranked it up to 7 tables. And now instead, what we're doing is we're cranking it up to 3 tables and then encrypting it and then chaining it with a few other tricks thrown in. And it would be really nice if we had just known day one that you needed to do that. But it took us 2 years to figure it out. We finally figured it out. Um, there's a lot of devil in the details there. Um, and a bunch of other stuff about match bits and stuff. But basically, our original construct is you have a bunch of positions and you hash them to values, and then some of them collide, and then you sort them, and then some of them collide, and you hash them again, and you compare to other values, and some of those collide. And so the colliding, the checking if you match and hashing together thing is one of the things that's done. Some of that is going to be done using sloth because it has this asymmetry property, which is very, very good. Um, and that's a different algorithm. That's a much mathier algorithm. It's like x cubed and then do XORing stuff in between. Um, and then there's the other place where this is all used is in the encryption step. So when you get to table three, you have like a complete table three entry that has, whatever number of bits in it. It's a 28 times 8 bits. And then you drop most of that shit and you wind up with 56 bits. And then you encrypt it. Um, and that encryption step has actually a much weaker threat model than most encryption does. But it needs to obfuscate pretty thoroughly what's happening in a way that's reversible. So you can go backwards and find out what was there before. Um, uh, where with sloth, the important part of the reversibility, in the place where you were using sloth, the important part of the reversibility thing is because that can be used as verification. Where here it's actually the reversibility is because you've dropped shit and need to get it back again. um, so um, uh, so when you construct a proof with the new format, when you construct a proof of space, if it hits, right, if it is good enough either to make a block or to make a partial for your pool, you then need to do what's called solving it. You need to take those bits that were dropped. You decrypt, which you can just do, and then you need to take those bits that were dropped and reconstruct them. And there's some amount of computation involved in doing that. That's one of the things that we have to, play games with in our parameters to make it so that the costs of doing that are not excessive. We have enough room to maneuver that we can be a little ridiculous and make it so that you can, in principle, do your solving on like a Pi 5, but it might take like 20 seconds and be running dangerously up against time. But that's one of the things where we can actually improve our resistance to grinding significantly by making it so that the costs of solving are higher. And the aggregate costs of solving are always very low. It's just a question of what is the latency on doing it any one time because it needs to be done before the block is due. So if we made it so just like a completely normal desktop took like a full second to do that, our security it would help our overall security, but kind of make it so that a i5 couldn't do it. Maybe we're being ridiculous trying to maintain that. We, we are open to feedback about how necessary that might really be. But yeah, I think that answered the question. I mean, that was a very technical, jargon-heavy answer, but that kind of covered on a technical level, I think, what we're doing with the encryption.
Yeah, and when we get into AES encryption, there's only so high of level that you can really get to.
Yeah,
You touched on the Pi 5 and support for low-end hardware. I know that's
yeah,
been a big motivation as to how the proof of space has evolved over the last 2 years. It's been created and redesigned.
yeah.
What are some of the reasons as to why supporting low-end hardware protects net space or decentralization long term?
Well, you want it to be that people can farm on the cheapest crap available. Um, the For solving the thing is for solving, it doesn't actually have to be done on the machine that's doing the harvesting. So, uh, so maybe we can loosen up that requirement quite a bit for that reason. That it doesn't. There's some work that does have to be done on the machine that's doing the harvesting. In particular, the disk load. That you're just stuck with that. Um, but that's something that in our threat model been doing. We've been kind of assuming it isn't offloaded from the actual harvester machines themselves, but it could be done. So maybe we're being ridiculous.
Oh, understandable. Thank you.
Yeah.
We're going to dive in a little bit more into the technical details here. We have a three-part question in our Q&A section here,
Yeah.
and I'm going to be typing this out as you're explaining it. So I'll go question by question as the user has provided them. The first one is relation finding bottleneck. Is the sieving phase for generating new class group discriminants still strictly CPU bound in your roadmap, or are you exploring hardware acceleration?
Um, so generating class group discriminants is not a significant contributor to latency that we're doing right now. Um, it is very, very fast. I think we haven't even bothered like properly parallelizing it. Because of that. I'm not sure how much benefit it could get from parallelization because it's like using the AVX acceleration. I don't know if that's on all the different cores separately or what. That's getting into arcane stuff that I'm not super familiar with. But we had discussion about this recently, and yeah, basically it's not contributing anything. Like it's not even worth trying to offload it to a GPU because by the time you've tried to send a message to the GPU and gotten a message back at all, it's taken longer than the CPU would have to find the discriminant.
Mm, Yeah, makes sense for sure. And the next question from the user, a GPU-based question as well here,
Yeah.
is for security auditing. Do you see value in accelerating this phase by 300x via GPUs to perform rigorous stress testing, crypto-analysis of
Um,
existing parameters, or is the current CPU speed considered good enough for security audits?
yeah, it's considered good enough, and we're also very locked into very specifically the exact algorithm that we're doing right now. Like it kind of has to be these 1024-bit things that are generated in a very specific way.
Thank you. And the last one from this user is in regards to scaling.
Yeah.
If Chia moves to 4096-bit discriminants in the future, how do you plan to mitigate the exponential slowdown in parameter generation
Uh,
without GPU offloading?
yeah, we don't plan on going to 4096 discriminant in the future. Right now, I believe 1024-bit discriminants remain utterly untouchable. I don't think anyone's even come close to breaking a 512-bit discriminant, much less breaking a 1024-bit discriminant and doing it in less than 10 minutes. So we doing just fine on that security parameter.
Absolutely. Thank you. Thank you. I went ahead and typed up all those for that user. I know they wanted to translate them as well, so they can see those responded to in the answered section now.
Mhm.
To wrap up our conversation regarding POS 2, what can the community and developers, anybody interested, what can they do now in regards to POS 2?
Um, I'm not sure off the top of my head when we're going to have a here, this can make plots, and so you can see how long it takes to make plots and stuff utility. But we will make that toy available at some point, which will at least give people some familiarity with what it will be like to run the stuff. Um, and probably the first version of that won't necessarily be completely um, it won't necessarily be the completely final thing, so don't start replotting everything. Actually, your plots won't work yet. You don't want to replot until the old plots stop working. But that will be available soon. I'm not totally sure exactly status on that. We're very close to that one.
Yeah, very exciting. And I know Dr. Nick is working hard to update that Proof of Space 2 chip, which includes the repo for that plotter.
Uh,
So if anybody is interested in that, feel free to take a look at the chips repo on GitHub. Keep an eye on the actual plotting repo that's associated with it, and that'll be the best place to get that information.
yeah, the dropping of table 4 and 5 really dramatically simplify implementation. It's very nice from that standpoint. Yeah.
Most certainly. And let's go ahead and touch on gaming for the rest of our call here. We had a big update occur last night. Do you mind covering what we released and what's now
Yeah,
available?
yeah. So we're in alpha. I want to emphasize this is initial alpha. We have known issues, which we are rapidly fixing. It will improve dramatically on a scale of even days and definitely weeks. But it is a thing you can play with that will show you how Chia Gaming works and how the hooks into it work. This is an alpha and not a beta. In the process of putting together the alpha, which is always good to have a running thing because it makes you realize a whole bunch of stuff. Realize the whole flow of it is not quite right. So right now, the way it's set up, well, all right, we want there to be the vision of the whole thing is we have an ecosystem, right? And there's multiple um, uh, uh, game clients that are web-based and maybe applications in the app stores in the future once people can figure out how to get those into the app stores. And and then there are what are called trackers, or we might call them something else in the future. But the trackers kind of act like, like IRC servers or Slack channels or something like that, and help people find each other. And but they can have much more advanced, just custom bespoke web interfaces because people can make whatever they want for those. Those are dynamic web pages. And then yeah, so the idea is there are multiple games that can be played, and anyone who wants to there's interoperation between these, that all of the game clients speak to all of the trackers and for the most part, play all of the games. Obviously, not literally all of them are going to play all the games, but that we don't want there to be lock-in of like anyone being like, oh, if you want to play this one game, you need to use our client. We want this to be an open thing where there's multiple vendors of all of these things, multiple vendors of web hosts, multiple that game clients, multiple vendors of trackers, and multiple games that people are introducing. Um, and the way we have it set up right now, like the tracker like helps you negotiate the terms of the actual game that you're playing, and that's not a good way of doing things. So we're going to change things. Actually, Mr. Dennis raced ahead of us a little bit in doing this, and we're going to, and he made some much more expedient decisions than we did. And we're going to be simplifying things mostly in the direction of what he's doing. So we're going to make it so the tracker's just there to help you find people, and you just start a session. And then within a session, you do all of your negotiation of the game to play within that session. Um, and that simplifies a bunch of the protocol stuff, also makes it so we can simplify the architecture of the front end quite a bit. The idea is that you want to, right now, like when you start a session, your tracker interface disappears, and we're going to change that so you have a tracker interface that stays there when you start a session, and those are kind of siblings of each other. And also, right now, we're putting too much work on the front end interface of individual games is like giving you information that it shouldn't, like your total balance and stuff. So it should be that there's an outer thing that knows your total balance, and the inner thing that just knows about the one hand and just knows about the amounts that are at stake in the one hand and the status of that. So yeah, a bunch of uh, simplifications are going to happen. So anyone who starts running one of these things now, we're going to change the whole flow fairly soon. Uh, but that's all going to be in the direction of clear improvements and simplifications. Um, the other thing we're going to be doing, which I'm very much looking forward to, is supporting more games. So we're going to take the California poker implementation and we're going to be refactoring it in ways that make a lot of sense to be simpler than it is right now. And also adding these other two games that I've spoken about before to kind of show what the platform can just do in general. Here are examples of good games that show you what can be done. I think we're going to do a good job of the protocol design and of the game design, and other people will be able to make splashier front ends very easily than we can because that's not our expertise around here.
Yeah, completely understandable. And feeding off of what you said, we want to make sure that the ecosystem can go out and build these things. And to
Ah,
help support that, we've started an RFP process where we
mhm,
are asking people to submit their proposals, show us their ideas, and then also provide a demo by the end of it if you're one of kind of the top ones. Do you
mhm.
mind going into a little bit more detail as to kind of what we expect from the community builders and what we're looking for within those proposals?
Uh, um, well, we're little, basically, well, we're a little limited right now in the sense that our thing isn't super high quality, so it isn't that easy for people to build on it. Um, but basically, the obvious things, there might be more, but the obvious things are game clients, trackers, and games. So, so people who can demonstrate that they've built those and have future plans for them, that's all very welcome. I'm not sure totally of time frame that we're putting on it because I'll feel a lot more comfortable um, about people's ability to do that, to do those things within the framework of the vision that we have after we get um, get things to a basic level of quality and flow. Once we get things working in the new way, where the tracker is not helping you negotiate the terms and just setting up a session, blah blah blah, all that stuff. We will see how long it takes for us to make those changes. Right now, we're still very much in debugging mode, but hopefully, fingers crossed, the being very much in debugging mode is on the scale of days, and the big-ish transitions we want to do is a little more on the scale of weeks. But we'll see how that all goes. Yeah.
Yeah, I agree. And I know we've talked about, extending that RFP process, looking
Yeah.
outside of that as well as needed. And if anybody is interested in participating in that, kind of the first step is a Q&A period, which is open now for the next few weeks. If you do have questions regarding the RFP process about what we're able to provide to you, what we're expecting from you as a potential developer or partner, feel free to send in your questions to proposals@chia.net. If you want to read the information about the RFP, we do have that on the doc site in the dev guides under the Chia Gaming section. And of course, you can always jump into Discord and ask us questions there. Always happy to provide additional information and give you those links. One of the things that we've been asked about in regards to gaming itself is, we have the first game out. What are the next milestones, and what do we see about the other two games going into our primitive and being available for people to build on?
Yeah, so the next milestones, I mean, I've been babbling about the next milestones. So next milestones are getting a bunch of our bugs and known issues out of the way. There's a kind of big-ish lift of cleaning up how it interacts with our wallet and the blockchain. And uh, yeah, that one's hopefully that isn't too much of an effort. Um, and then there's uh, and then there's updating the whole flow through the whole thing, and then there's refactoring of California poker to work better. In particular, it to do a much nicer transition between off-chain and on-chain play because right now it kind of always acts like it's on-chain, which it shouldn't. And so that should be cleaned up, and it just internally should be refactored. And then there's supporting the other two games. I have I have a feeling that a lot of the game work is going to get delayed a bit here behind the other stuff in terms of order of operations because yeah, it's certainly all the things that are just internal to the games are kind of lower priority in terms of other people being able to interact with the whole thing. Um, which is a little annoying because I really want to work on the games. um, but that's probably roughly the order, but it's a little hard to say. So we've done this mad dash towards getting our alpha out. We finally got the alpha out. Um, Now we're gonna do this process of there is a backlog of work to do in it, but now the plan is we're basically just gonna from scratch make a new backlog of stuff to do, and then like get that kind of sorted and then go over the old backlog just to make sure that there isn't something important that we forgot when we were writing up the new backlog. But it's very much, when you do these big releases, often you take stock and your whole perception of the world has changed after having hit this milestone. So yeah.
Definitely. And to dive a little bit more into one of the things you mentioned there, with the gaming primitive, there's a combination of what's occurring on chain and what is occurring off chain.
Mhm.
Do you mind explaining a little bit about, what is a state channel, how it allows for that migration of on chain versus off chain?
Yeah. So state channels are well, in Bitcoin Lightning you have payment channels, and this is using state channels, which are basically the exact same thing. um, so the idea is you and I want to interact with each other, but we want to um, do it in real time. And we're sending money back and forth between us, but we don't want to wait for the chain between each of these events. So what we do is at the beginning, I take all of my buy-in and you take all of your buy-in, and we pull them together and make a single coin on chain that requires both of us sign it in order for it to get spent. And that thing has a concept of there being some state number, right? And uh, at any for any given state number, we can one of us can start unrolling it to that state. And what's going to happen after that is either the coins that are these virtual coins that are in the state that is off chain that we're doing become real, or the other person says, no, there's a later state number than that, and that later state number becomes real. And that's how it works. So we have these virtual coins, and we're playing on these virtual coins, and we try as much as possible to do that. So we have to, at the very beginning of our session, you have to wait for the session coin to get created, um, and then after that finishes, then and our startup time right now is waiting for a lot more than just one new peak. We can fix that. Um, Part of the low-hanging fruit that we're fixing right now. The After that goes through, we then play off chain, right? And if there's a problem, well, hopefully most of the time, what happens is we have a clean shutdown, that we just end the session and you and I just agree, this is what we were left with at the end. And there's just a single spend that just goes right back to both of our wallets from this single coin. Um, and the If there's a problem at that point, then if one of us just like completely disappears so they can't agree to this or anything, then the other person can unroll to the latest version, to the latest value of it. And that will, after the timeout period's over, become real. And then the whatever hand is pending at that time, that has to get played out on chain. Um, so the many levels of optimization here that you're trying as much as possible to avoid doing stuff on chain. And even when you do have to do something on chain, you've netted out everything up to that point in time. And then in terms of the actual game itself, the way game coins work, the two players just say what the new state is without actually giving the game logic. And the only time game logic itself ever has to get invoked is when somebody attempts to cheat and the other player says, no, you attempted to cheat. Here's my reveal of what's going on and my proof that you attempted to cheat. And then actual game logic gets invoked, but it's only the game logic of that final turn, in fact. Um,
Uh,
and then on top of that, we're just using games that have very few turns in them. so, so a lot of levels of optimization because using a blockchain is very slow and very expensive. And this is legitimately peer-to-peer. This isn't like we have some blockchain that's actually really a very centralized thing that has to be because we cranked up all the numbers so much that it couldn't possibly be decentralized. Um, which some other people are doing, but no, this is legitimately decentralized and we're doing the actual real engineering work necessary to make it so you can do things in real time over this very secure, very decentralized database.
yeah, very exciting. I know I'm very much looking forward to seeing when all this comes out and see what the community does with this and what type of builders we have coming about.
Mm-hmm.
So thank you for the overviews on the updates of Chia Gaming, the alpha release, the initial alpha release, as well as the updates on the POS2. We do have two additional questions. I'm hoping I can keep you for a little bit longer here inside of
Yeah.
our Zoom chat. And the first is, and I'm taking this as more of a general question to get your thoughts on, but when will AI appear on Chia?
We have no plans of doing much of any AI on Chia. AI. General rule of thumb, you don't want to let AI anywhere near anything security related. It's just a security nightmare in every way imaginable. So,
Completely understandable. And
yeah.
the other one that we have is regarding stablecoins. Um, which is more likely that Chia will take the initiative and invite the stablecoin into the ecosystem, referring to USDC,
Yeah.
or does the team expect the stablecoin to react to online activity and come on its own?
I really don't know. That sounds a little bit more of a Gene question than a me question. That because that kind of relates more to like what we're doing over with Permuto, which will hopefully create a lot of demand for stablecoins in doing transactions related to that.
Yeah, thank you very much. I appreciate your time today, and that's all the questions we had inside of our Zoom chat as well as our other resources. Did you have any final words for the community?
I have these mixed feelings about how much I want to pump alpha. I want to pump our Chia Gaming alpha release to everyone who it is appropriate for. So for all the devs out there, this is a great thing for you to go look at. Maybe wait a few days until the quality improves a bit, but really good opportunity for y'all to get in early on that. Although very reticent to encourage end users to try to play with it at all. Although technically you can right now, but very not much not recommended. Just
Absolutely. Yeah, and I know we're not hosting anything for end users to test it out or anything like that. It's
yeah.
strictly, hey, this is a developer alpha. Come
Mhm.
take a look at it, build with it, and submit your questions regarding the RFP.
Mhm.
So thank you for your time today, Bram. I really appreciate it. We got into a lot of great conversation regarding POS2 and Chia Gaming. And for those watching, keep your eye open for the next Bram Tech Talk. We usually do these about once a month, and we always get into the nitty gritty, but then try to cover the high level topics as well.
Mhm.
So thank you all. Have a wonderful day.